All right, so right now this is going to be a more in-depth example, and that is we're going to find the sine, cosine, and tangent of 15 degrees, and the way that we're going to find it is by using our half angle formula. All right, so we'll just start with sine, and we'll go on from there. All right, so let's just first write down what is the sine formula. So the sine, and I'll just use theta, theta over 2 is equal to plus or minus the square root 1 minus the cosine of u all over 2. And this sign right here, by the way, always is always negative, depending, and like that doesn't depend on whether this is a positive or negative. Okay. So if our angle given to us is 15 degrees, that means 15. Oh wait, this is theta right here because I'm doing theta. That means 15 is equal to theta over 2, right? I set theta over 2 equal to 15. So really my theta, if I multiply both sides by 2, my theta right here is 30. Okay, so that's going to be my theta, because if I take 30 and if I plug it in right here, what isn't 30 divided by 2, 15? Hopefully that makes sense there. If I take my theta, if I divide it by 2 right here, that should be the same angle right here. Okay, so the sine of 15 degrees is equal to, since 15 is in quadrant 1, I know the sign is going to be positive, so I'm not going to do negative. I'm going to do the positive radical 1 minus the cosine of 30 degrees all over 2. Well, let's go ahead and simplify this guy right here. Well, the cosine of 30 degrees is radical 3 over 2. So that's radical 3 over 2, and that's all over 2. Okay, so let's simplify the numerator and get a common denominator. So I'm going to multiply the 1 top and bottom by 2. So I'll get 2 minus radical 3 all over 2. So that refers to just the whole numerator. That's all over 2. Since these are both 2, I could just multiply them. So I get 2 minus radical 3 all over 4. Okay, and notice that my radical goes all the way down, because this means everything is underneath the radical. But until now, I'm going to do my next one, and now only 2 minus radical 3 will be underneath the radical, and then it'll be just 2. So notice the difference here, because I took the square root of 4, which is just 2, which means I would not drop the radical all the way down, or else it's incorrect now. It means something different. Okay, so the sine of 15 degrees is right here, radical 2 minus radical 3 all over 2. Okay. Let's go ahead and find the cosine of 15 degrees. Okay. Well, I'll just write it over here real quick. The cosine of theta over 2 is also plus or minus the radical of 1 plus now cosine of 30. I'm sorry, I'm not doing that yet. Plus the cosine of theta all over 2. Okay, so notice the difference. The only difference between the sine and the cosine is just the sign right here. So this is a minus and this is a plus. So really our answer is going to be the exact same thing, except instead of it being a minus, it's going to be a plus. So I'm just going to straight go to this and say my answer is going to be 2 plus radical 3 all over 2. But as a good practice right now, go ahead and maybe do the whole thing and see if you get this. But if you just look at the work here, if I made that plus, I make that plus, make that plus, make that plus, plus. So the process is the exact same. Nothing changes except that one sign. So I know the answer is just simply that. Okay. Lastly, let's do the tangent of 15 degrees. And this formula is different than the other guy. So let me write this guy over here. So tangent of theta over 2 is 1 minus the cosine of theta all over sine of theta. Okay? So let's do it then. 1 minus the cosine of 30 degrees all over the sine of 30 degrees. Okay, so if we evaluate both the cosine and the sine right here, we're going to get 1 minus radical 3 over 2. So that would be that guy right there. And then the denominator, sine of 30 degrees is just 1/2. Okay? So if I just continue down here, if I simplify the numerator, I'm going to multiply this top and bottom by 2. So I get 2 minus radical 3 all over 2. And that's all over 1/2. So see how they both have fraction, right? The numerator has a fraction and the denominator has a fraction. Well, if both fractions have the same denominator, wacha, wata, those just cancel out, and we're left with just simply 2 minus radical 3. And that concludes that problem.